Okay. All right. Oh, hold on. Let me move this on my other screen here. Um, Welcome back to another lesson, right? Let me just make sure I have this. Okay, yes. So yes, welcome back. So today we will be talking about, let me come in here, DHCP. Okay, so this week we talked about NAT, network address translation, which is again translating IP addresses from public to private or private to public. We talked about NTP, network time protocol, which is just all the devices in the network syncing up and agreeing on the time, that this is a time, right? So when you're working in a company, the CEO doesn't have a different time from, maybe the agents that's taking calls, that's in the call center taking calls or whatever. We want to make sure that this network runs off of this time, regardless of its delay with any other network. It is all synchronizing on what the time is, right? You have a client and you have a server. The server is going to serve you the time. The client's going to update the time from the server and broadcast that out to other devices, right? So today we're going to talk about DHCP, okay? Dynamic Host Control Protocol. Let's actually bring that up here. Excuse me. And let's get started, right? DHCP, Dynamic Host Configuration Protocol, right? This is a protocol that you're going to see is open source. So it's not like specific to Cisco. So you're definitely going to see this out in the field as a network admin, as a network engineer. This is something that you may even have to configure as a admin, right? Or even as a new engineer. It's just widely used. And the reason for DHCP is to allocate IP addresses. It's to dynamically assign IP addresses to to clients, right? If you look down here, as you see, the client is just a computer. DHCP client is a client that needs an IP address. So remember in a packet tracer, what we would do is assign IP addresses to the host. So we'll go into the computer and put an IP address in a subnet mask. But instead of, let's say you have like 50,000 computers, instead of like manually assigning an IP address for 50,000 computers, you have one server that hosts a group of available IP addresses. Like when we do our ranges, when we were subnetting, and we would say, find the network ID, the broadcast ID, and then the first usable and the last usable, right? So that first usable and that last usable are going to go into this pool on this DHCP server, which will allocate IP addresses to the end devices that need IP addresses and all that good stuff. So that's the basis of DHCP. It's just a way to assign IP addresses to where we're not manually doing it for every single host. Okay, DHCP is a client server protocol. As you can see, just like NTP, right? We have a client that asks the server something, and then we have the server who's going to serve the client information, right? That's all that is. It says a DHCP server maintains a pool of available IP addresses and assigns one of them to the host. That's all it is, right? Cisco routers can be configured as both DHCP client and a DHCP server, right? So you don't necessarily just have to create it on a server, right? Maybe like a Cisco MCS or a Cisco, I don't think that's MCS. I don't think those are probably still making. So a Cisco, one of those cloud servers, you can definitely use that. You can virtualize it and create a DHCP server, or you can configure this on a router and create and make the router a actual DHCP server, which this is where you're actually going to learn. Let me see really quick if they just want to describe or actually want you to configure. Here we go. So required text, for some reason, I Should probably keep this up. Oh, I think I already had it up. Let's just look at week 4 really quick. Explain the role of DHCP. Now it also says DNS, but DHCP is, I want you to kind of really understand it in full. And then tomorrow we'll talk about DNS, SNMP, and system logging. We'll talk about all of that together because again, it's just a paragraph or 2 about each topic. But anyway, back to where we're at. DHCP, yes, it's just explaining. So I honestly suggest you configure this so you can have this as a skill that you've actually, can talk about DHCP, because these exact commands, when you do in Packet Tracer, is literally the same thing you're going to do on an enterprise router, right? So this is exactly what you're going to be doing. So why not do the labs, gain that experience, be able to put it on your resume, even if it's something like I have configured it in a lab environment or in a quote unquote internship environment. But anyway, so DHCP servers provide parameters like IP address, subnet mask, default gateway, and DNS. Okay, the DNS server is going to provide all of this information to the client. So the DHCP client goes through 4 steps, right? So what happens is we have this computer and the computer decides to get on the internet. So as you can see here, I have my Wi-Fi. Let's say I wasn't connected to Wi-Fi and I wanted to. So I would click on here and I click on, my networks, and I would figure out which network do I want to connect to, okay? And then I would connect to it. Now in a enterprise environment, like let's say you're working for, Comcast or something, your computer would be hardwired and plugged in already through like an Ethernet cable. Or even if it's not, let's say you are on a laptop, you will connect to the Comcast or whoever you're working for network, okay? So you're connected to the network. Your client is going to go through these 4 steps, and the steps is called DORA. That's how we break it down, DORA, DORA. So the client first has to discover, right? It has to send a DHCP discover message. It's a broadcast message to the server. Now, the DHCP client does not have an IP address. It doesn't have anything. So obviously we say, well, it cannot talk. It cannot send a message outside of its own network. But what it can do is it can send a broadcast message to the DHCP server to say, hey, I need some information. I need the IP address. I need these parameters: IP address, subnet mask, default gateway, and DNS. Okay. And then the DHCP server is going to respond with an offer, right? That's the O. So the client says, hey, is there a DHCP server out there? I need some information. I need an IP address so I can start routing traffic. And the server says, okay, well, let me send you an offer. And that offer is going to be an IP address, a domain name, and a lease to say, this is how long you can hold on to this IP address. Okay, so, hey, what's up? Let me get some information. That's the discover. And then the O is the offer. The DHCP server actually offers the client some information, right? And then the client comes back with a formal request and say, well, you know what? I do like that IP address and that domain name and that lease. Let me go ahead and take that. Now it's a broadcast message because, they don't have an IP address. The client has nothing. So the client's sending broadcast messages like, hey, DHCP server, can I get an IP address? And the server's going to say, well, here's an option. Here's some info. Here what I can offer you. And then the client's going to come back to the DHCP server and say, oh, well, you know what? I'll take that information. Thank you. And then the server is going to confirm with the client and make sure that the client has those parameters: the IP address, the domain, and the DNS, subnet mask, all that good stuff, right? So it's going to acknowledge and say, okay, cool. Since you said you want this, here you go. Okay. Now, what's really big is the well-known ports. DHCP uses 2 types of ports, one for server and one for client. please make sure you do not mix those up, and make sure you definitely know the difference, because it was on my exam. And what I just thought about too was, when I was taking my exam, there were a lot of questions that were related to port numbers and port protocols, like did it use UDP or TCP, and what was the port number. I would say that was a good like 10 questions. So if my test is only 50 questions and 10 of them has to do with port numbers or port protocols, and let's say I've actually been studying that, which I really was heavy on that because I didn't know, which ones they were going to talk about, or if they were talking about them at all. And I studied them, and I know I got those right for sure. So I know that, hey, I got 10 questions right out of 50 questions. So I'm getting somewhere. And those are like really easy questions that you don't want to get wrong, because again, imagine, you don't have all the CCNA in your head, and you don't know what the questions they would ask, and you just skip out on actually being able to just remember the easy stuff like port numbers, right? So just remember that DHCP uses port number 67 for server and port number 68 for client. And they're both UDP, they're both broadcast. Okay, that's what DHCP uses. Now, another thing, make sure you understand DORA. DORA is so important because that's the backbone of DHCP. That's how DHCP works. And you may even get a question if you're deciding to become a network engineer or a network administrator. You may even get a question in an interview to say, hey, how does the DHCP process work? Because it's very well widely used. So how does it work? And then all you have to say is, well, the DHCP goes through a process, which we call DORA, right? So the client's going to send a discover message to discover the DHCP server. The server is going to offer the client the IP address, the domain, the subnet mask, all that good stuff. And then the DHCP client is going to send the server another message, which is a request, and say, hey, I would actually like that information. Can you give it to me? And then the server is going to acknowledge that request and allocate that information to the client. Now, the client has that information. The client knows its default gateway, its IP address, its subnet mask, and even its DNS, its domain name server. And now they can start talking to people, talking to other devices on the network. Right? Simple as that. That's DHCP. Now, if we want to go in and do all this other stuff, we can Google it. But for an interview question, this is exactly what you would say to them. Okay. Moving on, the Cisco iOS DHCP client offers the following benefits, right? So the DHCP client, if you was to configure it on a router, reduces time to configure and deploy. It does it automatically. So there's no need to sit here and actually assign an IP address for every single device on a network. That's great if you're in a small network, but imagine you're in a network like you work for Amazon. Imagine having to assign all Amazon employees an IP address. That would just be ridiculous, right? So instead of doing that, you can deploy it automatically, right? The client will automatically reach out to the DHCP server and say, hey, I need some information so I can start routing, right? It reduces the number of configuration errors. No need for fat fingering or wrong key, right? Because let's say we do have 50,000 host computers to configure IP addresses and domain names and default gateways to. We might get a one. It may say, 192, but then we put 172, or instead of putting a dot, we put a comma or something. It's a lot of room for human error. So why not configure it so it can automatically be ran? And then it enables customers to centrally control the IP addresses assigned to a Cisco iOS router. Again, it just keeps all our IP addresses in a central location, which is all good. Okay, so DHCP offers a lot of benefits, and that's why it's used so widely. So you're definitely going to see this out in the field. And even if you are not, a network engineer or a network administrator, you still will see this somewhere in the tech department. You'll hear it, you'll see it, something like that. And the best way to know definitely is to just go to, you know, your command and, you know, IP config, I think it's IP config all. Yep. And as you can see, you know, during troubleshooting, even if you're not in tech, you may have to call out for troubleshooting, and who's ever troubleshooting with you may ask you to run this command, IP config all, to where they're going to say, what's your IP address? And as you can see, this is where all DHCP information is going to be here. You see? So here's my DHCP server, right? That's the IP. Here's my subnet mask, my IPv4, you know, my default gateway. So if you ever want to look at your own DHCP information, or you want to troubleshoot on an end device, IP config all will definitely get you that information. Okay. So there's a couple keywords here with DHCP when you're talking about configuring it. So one is a relay agent. So a relay agent forwards requests and replies between clients and servers when they are not on the same physical subnet, right? So this agent will listen to DHCP discover broadcasts and forward those packets to a specific server, right? And then the server can exist on any type of network, right? This allows a centralized DHCP server to be used for multiple subnets. So you have a server that, you know, a DHCP server that you can use in different types of networks, right? Because like I said, when the client comes on board, comes onto the network, the host does not have a IP address at all. So what it needs to do is it needs to send out a message to the server. But how does it send a message to the server? It doesn't have an IP address and it can't route or anything. It sends that broadcast message, but we have to have a relay agent. It's an agent that relays the messages. Like, it's kind of simple in its name, right? So it's most likely going to be that router that says, hey, I'm going to be the middleman between the client and the server until the client can actually figure out what's their default gateway and their IP address and know where to route it, right? We call that a helper address. We configure it on the default gateway. Like I said, on the router between the client and the server, we're going to configure what's called an IP helper address. And that IP helper address is an address that listens to DHCP broadcasts and forwards them, right? It's just an agent that relays information, okay? It says client and router-based DHCP connectivity issues are typically the result of misconfigurations. So if your client is not getting any IP address or any information from the DHCP server, or the DHCP server is just not sending out anything to the clients, it's usually because something was misconfigured. Right. So when you are troubleshooting DHCP, you definitely want to use the show IP DHCP command, so you can detect any type of conflicts or anything that's going on. These are like some questions that are really good when you are troubleshooting DHCP, because again, like I said, it's misconfiguration. So maybe you didn't add the helper address, or maybe you didn't put the correct pool of IPs in, or maybe you don't have enough in the usable range of IPs. Is there something going on with the server? Maybe something actually is going on with the server. Maybe there's something actually going on with the middleman, the relay, or something with the actual host. It's some type of configuration that you need to definitely troubleshoot. And these are good. It says, is the issue with the DHCP server? Verify DHCP configurations on the router is correct. Is the issue with the DHCP relay? Remove the relay from the equation and see what happens. So this is actually good. I would probably keep this in my back pocket. And then simple configuring and verifying. Now remember, verifying is a show command. These are all the show commands for DHCP, but show IP DHCP pool is really good. Show IP pool binding. I put a error here. See, human errors. I should have put a P as an O instead. But the first thing you're going to do when you're configuring DHCP is go to the server and configure it. We low-key did this in our last lab. I'm starting to remember that. Let me see. I forgot what lab that was, but we actually configured the DHCP server. So, so you kind of should already be familiar a little bit with some of this. But what we're going to do is we're actually going to create a router. Let me see, what's in the lab? Yes. So the lab has the routers. So you're actually going to go into the router and configure it. And the first thing you're going to do is you're going to say, hey, I want to exclude this address. Okay. And this address is our default gateway. It's our address that's already accounted for. So we don't want to use it. Okay. And then we're going to, we're going to create a pool name. And it's going to be IP DHCP pool. And what's the name of the pool? We can say floor 1 DHCP. This is just an example, but it can say anything. Maybe you want the pool to be, named after anything, named after the state or a city or something proprietary in the network. Once you put the pool in, you're going to say, this is the network address. Because once you say that it's going to be an IP DHCP pool, you name the pool, then as you can see, you go into a DHCP configuration terminal. So now you're actually configuring DHCP now. So I want to tell DHCP that this is my network address. Okay. So this is where you have this pool, is where you can get the IPs from. This is my default router. This is the IP of it. And this is my DNS server. So when you want to go out here and send the client the parameters, you're going to send the server, the router, and make sure that they get to be in this IP pool range. Okay. So that's what you do on the router. Boom, you're done. You can even do show IP DHCP pool to verify that everything actually has been taken care of. Then you go into your relay. Right? Your relay is the interface where your default gateway resides. So again, it's just your router and the router between the client and the server. You're going to go into the interface and put in this command. Interface, whatever the interface is, and you're going to put IP helper address 172.16. Well, obviously not this, but you're going to put IP helper address in whatever the IP is. Okay. Most of the time, this is exactly the same device. I'm not gonna say most of the time, but definitely when you are working in a medium-sized environment, you can do this on the same device. And then the client, obviously, we're gonna say, hey, you're gonna get your IP address from DHCP. And again, the client, we can do it anyway, but for this example, they want you to do it on the router. So you're just going to say, hey, this is where you get your IP address, which is, specific interface. And then that's it. You're just going to verify, use your verification, your show commands, and you're just going to make sure that everything is configured properly. And then you would go into the interface, make sure it has an IP address. You would go into, if it's a computer, like a end device, you can go into the IP config all and make sure that you got an IP address and all that good stuff. And then, DHCP is there working. Like I said, we did this kind of already before. It's just we used the server and packet tracer to where it gave us a nice little GUI to where we can actually put in the IP address, and we can put in the excluded address. And all we had to do was check mark and click save. And it was very nice, easy interface. But as an engineer, what do? We build things, right? So we are engineering things. So we're going from scratch and building it up. So instead of using this great graph GUI that software developers created, we're actually going to go into the terminal, right? We're going to go into the command line and configure these with commands, right? And then that makes you a badass. So we know what DHCP is. Let's just verify it really quick. Dynamic host configuration protocol. Okay, all it is a way to allocate IP addresses in a network automatically. So you don't have to do it manually. right? And networks want to be, when you are coming into an IT department, is all about scalability, because a company is always wants to grow. There always wants room to grow. So yes, we have 5 computers now, and it's easy to put IP addresses on those 5 computers. But what happens when it gets to 50? What happens when it gets to 1,000? What happens when it gets to 100,000? You're going to have more than one person configuring IP addresses. You're probably going to have a whole team that just configures IP addresses. And that's probably like thousands of dollars that you're, hundreds of thousands of dollars that you're spending on employment and wages and stuff. So to cut that down to where that money can go more into reinvesting in the company, why not configure this protocol, DHCP, to where, instead of having a team of 5 configuring IP addresses, you have a team of 1, because all they had to do was run this command. Use this protocol, right? DHCP servers will send out these parameters: IP address, subnet mask, default gateway, DNS server, right? And it's going to go through a process, which is DORA. So the client's going to discover the DHCP server. Hey, server, I need some information so I can start sending packets. The server will say, oh, okay, well, let me give you this information. Would you like this? The client's going to say, yes, I actually do like this. Can I have it? And then the server's going to say, oh, you want it? Here you go. And it's going to give, again, all of these parameters. All right. So it goes through DORA: discover, offer, request, acknowledge. Okay. Here's a little bit down here so you can kind of read a little bit more. Remember, DHCP uses port 67 for server and port 68 for client. That is so important. I use those ports a lot when we are opening and closing ports for certain applications. And we just have to make sure that we have 67 and 68 open and not closed because of DHCP. And then relay agents, again, it's just an agent to relay information between the DHCP client and the DHCP server until the client gets everything they need. And then, of course, there are show commands that you can verify everything. But the main objective is to make sure that you understand DHCP fully by actually going through the labs, right? And here's a lab right here. Very simple, very easy. 2 routers, 2 devices. All you're doing is configuring one as a relay agent, right? And one as the actual server. So this will probably be a DHCP server. This is the default gateway, the relay agent, and then you have your host. Okay, so your host will get their IP addresses from the DHCP server, right? And the relay, the agent, aka the IP helper address that you will configure here, will relay the messages from the computer to the DHCP router here, so it can get all its parameters and start talking to whoever they want to talk to. Okay, so definitely do this. Again, these are really great because they make you configure these things that are on the exam, right? So, so if I was to say, hey, actually with the exam, you have about 10 questions that's all about port numbers, right? So you got them right because you've been studying port numbers. And then you have another 10 questions that's how do you configure host name? How do you configure the console? How do you configure virtual terminal? How do you enable passwords? How do you open interfaces? That's 10 questions too. So that's 20% of the exam. And those are easy questions, right? So, again, you want to definitely make sure that, you have more rights than wrongs, right? So definitely make sure you do these things that are muscle memory. DHCP, they will ask, and that's why you're doing it here. So you can know exact steps on what to do because they will ask you. And again, I love these because they ask you questions, right? What were the IP addresses assigned, right? Like, it makes get your wheels turning. And then of course it gives you the answers. Okay. I do have this here. What is this? Things you should know. If you do not know these go back and review period chat. Okay, so let's see. What is a router? This is good. We're not there yet with this. So I may give this to you guys. Actually, I'm gonna probably things you may not know, but should. Actually, you should know these things. I'm probably gonna save this. Let me save this. You guys can review this. I'm probably gonna put it in the Discord. But anyway, regardless, do your labs and go over it, read. Let me just make sure IP services. Yes, DHCP, go over your reading. Make sure you have a full understanding of what DHCP is and why we use it, right? So with these protocols, make sure you know what the protocol is, what's going on with it. And the best way to get your head wrapped around it is to say, why are we using this? What's the use case of this protocol? Okay. And once you get your head wrapped around the use case, then it should be easier for you to remember the acronym and what it's about. Lab is always a good way to wrap your head around these protocols even more. We have DHCP right here. I already showed you. Please make sure you are knocking that out. And then last but not least, we have, get that out of my way. We have the flashcards. Flashcards are great. Okay. Again, I don't do much. Oh, here they go. I don't do much of the flashcards. I kind of just do enough. But if you feel like you need to remember a certain term that I don't have on these virtual flashcards, definitely make sure that you create your own flashcards and add ones that are not here. Okay. So yeah. That's really it, you guys. If you have any questions, comments, concerns, or want to chat about getting a better job or getting into the tech field or just getting a newer job or a remote job, whatever, don't hesitate, reach out. That's what we're here for, increasing our income through tech, whether you get the CCNA or not. The CCNA is for you to become a network engineer. So you can actually step into that engineering role and get paid to the 6 figures. You can get 6 figures without the CCNA. It may be a little more work, but it's still possible, right? Nothing is impossible. So always make sure you're in Discord looking at the jobs that I post. I try to post them every day and apply to those. So if you feel like you need resume help, reach out. Obviously in the job board, definitely reach out as well. Okay. So yeah, that's all I had today. Tomorrow we'll talk about DNS and some other protocols. So make sure you get your head wrapped around DHCP so we can keep it moving. All right. So yeah, pretty simple, pretty easy lesson. Until next time, we'll talk about DNS and some other things. So